check your answers on these two. I'm not going to do them out, but I did them out earlier. Take a look. So after this moment, all 12 of these should be done. If they're not done on your paper, you need to do them. Do you guys have any questions? Oh, yeah, of course. Guys, you guys good? You sure? Okay. Today, guys, I love you. Quiet for a moment. We are doing a resource page in the packet. It's number 132 and 134. If you could locate it, we're getting deep in there. The one right after the pre-calc problem. So find that. This is the last actual lesson of the unit. And then Monday is review notes, just to give you a heads up where we're at. I'm thinking that, guys, I'm thinking that after Wednesday's pre-calc problem, this should be very easy. So all we're going to do today is the same thing you did, practice writing the equation from the graph. So we're going to have a graph given to us. We're going to figure out K, then A, then the period, then B, and H somewhere in there. So, and then write an equation. The one main thing I want you guys to take away from this is that all sine and cosine waves have infinite equations, depending on where you choose your locator point. A lot of people, interestingly enough, yesterday had different equations for their pre-calc graph than I did, but they got all the same answers because they just picked a different locator point than me. So anyway, it's going to be very easy. Homework is 136 through 139, and there's my joke. Just give it a minute, let it hit you. Do you know who that is? It's probably a good thing because he's not really a great guy, but okay, I'll give you a hint. His name is Bill Cosby. Oh. Sine B over tan B equals Cosby. Cosine, yeah. Mm. Pretty good. I was too dumb to. Okay, here we go. I'm going to use a straight edge, just like we did before. Find my midline and whatnot. Okay. State the amplitude, period, phase shift, vertical shift, K of each function, write 4 possible equations for each curve, one of each in terms of positive sine, positive cosine, and negative cosine. All angles are measured in radians. Here we go. Okay, now I noticed the midline of this graph here, this first one is on the axis itself. So the first thing I'm going to do is mark the midline. Midline is at 0, so K is 0. Okay. Then I'm going to mark the top and bottom, and that helps me get the amplitude. It's 3 units up and 3 units down, so A is 3. Okay, now I'm going to count the period, and I'm going to start here and end here. I always like to count the period from the y-axis if I can. So I notice that it's starting at the bottom, so I want to find out how long it takes for me to end at the bottom. Can you guys tell the period is pi? Okay, super important that you guys can tell the period is pi. Okay, B is 2 pi over the period, which is 2 pi over pi, which is 2. This is a formula. 2 pi over the period. Period is pi. Okay, now here's where it gets weird. We have an infinite number of answers. And what I want you to do is start with your first locator point here on the y-axis. Okay, so before we do anything else, this coordinate right here is 0, -3. Are you guys okay with the 0, -3 coordinate? Okay, so there's actually an infinite number of h's. The first h I'm going to choose is 0. Okay, let me say that again. There's an infinite number of h's I can choose. My first h that I'm going to go with is 0. Okay, so come up to equation 1. What type of graph would this be if this was my locator point here? Which one of these 4? You have 4 options: positive sign, negative sign, positive cosine, or negative cosine. Negative cosine. Okay, so y equals -3 cosine 2 x minus 0 plus 0. Okay, pause there. Any questions about where I got this stuff from? So let me say it again. Y equals A cosine B x minus h plus k. Okay, now, you guys with me? You sure? Did I do it wrong? You're talking. Okay, now I want you guys to move to the next locator point we're gonna pick is on the x-axis here, and this coordinate is pi over 4, 0. So that means my next h is pi over 4. I'm gonna put 4 of them in this box. Okay, now what I like to do is I like to take my hand and block out everything before that locator point and say, okay, if this was my locator point, which type of graph would I have? Positive sign, positive cosine, or negative cosine? Positive sign. Okay, so come back here. Y equals, it's a positive 3 sine 2 x minus pi over 4 plus 0. Okay, where do you think I'm gonna pick my next locator point? At the top, great job. This coordinate is pi over 2, 3. That means my next h I'm going to pick is pi over 2. Okay, now I block everything out with my hands. What type of graph is this? Positive cosine, perfect. Okay, y equals 3 cosine 2 x minus pi over 2 plus 0. Are we getting the hang of what's happening? And after doing yesterday, this should seem not elementary at all, but at least it doesn't have a bunch of decimals in it. Okay, last locator point I'm going to choose is this one. This is 3 pi over 4, 0. So my last h is going to be 3 pi over 4. And on my h box, I'm going to put comma dot dot dot. That reminds me that there's infinite answers. And I could go backwards also, but we don't need to be doing that. Okay, now blocking this off, there's only one option left, negative sign, right? Y equals negative 3 sine 2 x minus 3 pi over 4 plus 0. And of course, when you guys see these graphs or when you see these equations, the zeros wouldn't be in there. I'm putting them in there for an emphasis on where every little piece goes. I want you to see where each piece goes in the equation. Do you guys have any questions about 132 before we move on and go again? So we're just getting back on the ride and going again in number 134. Okay, so scroll down. Okay. Start with the midline. Let's see. Okay. Next thing I like to do is figure out the period, and I start my wave at the y-axis every time, and then I just have to be like, okay, where would it end? It would end right here. Can you guys tell that the starts here, ends here? It's one cycle of the wave. Okay, so that means the period is 4 pi's. 4 delicious pies. Okay, now B is a formula. It's 2 pi over 4 pi, which is 1/2. Okay, I'm going to start my h at 0. I'm going to do that on this whole worksheet. I'm going to start my h at 0. This coordinate is 0, -1. So the first h I'm going to work with is 0. To be honest with you, the first h I'm going to work with is 0 on all of these. Okay, what type of graph do I have if that's my locator point? Negative sign. Great job. -2 sine 1/2 x minus 0 minus 1. Okay, now I'm going to go to the bottom. This coordinate is pi -3. So my next h is pi. Okay, what type of graph would it be if I started here? Negative cosine. Okay, I'm going to mark the next two locator points. They're right here and here. I want you guys to try to find these two equations on your own. So this is the next dot. This is the next dot. Try to do it. Don't look up here. That's cheating. You don't look up till you're ready. Okay, flip to the back. There's I believe, if I remember from last year, the first one is spicy and the second one's easy. I'm gonna help you with the first one. Way back. I think the first one's spicy because there's lack of labeling. So, I think the second one's easy. I'm trying to remember. It's been 365 days since I've done this page. You guys can try the top one on the back if you want. Yes, and is it hard though? I feel like it's hard. No, it's not. It is? Oh, so you don't need me? We don't ever want to make you feel not needed. Oh, I know what it was. Okay. All right. So Okay, so um, I'm hoping everybody can see K is -2 on this one. Are we good with that? Okay, amplitude of 1. I tried to trick you there with the scale, but you probably didn't fall for it. Ooh, Mrs. Talbot, so tricky. The ones. Okay. Now this is a challenging bit. There's a couple of challenging bits right here. First, I want to find the period. So I put start here at the y-axis, and then the wave ends here, which is pi over 2. So that's my period is pi over 2. But how do I do this? Okay, so 2 over pi over 2. Okay, keep, change, flip. And the pi's cancel, and you get 4. Okay, now the last thing, that's not really that bad. Let's start our locator point on the y-axis, which I like to do. This point is 0, -2. What's wrong? Did I do it wrong? Are you sure? Okay. Um, that what I wanted to talk about here isn't this equation. So can you guys all see this one would be negative sign, first of all? Okay, so we have y equals -1 sine 4 x minus 0 minus 2. Okay, that's not really what I wanted to discuss. It's what is this coordinate here? There's no label. So what is halfway between 0 and pi over 4? Pi over 8, yeah. So you just cut the 4 in half, or you mean you just multiply the 4 by 2 to get the middle. So this is pi over 8 -3. Okay, and then if I start at the bottom here, this would be negative cosine. So y equals -1 cosine 4 x minus pi over 8 minus 2. Okay, now this is easy. This is pi over 4 -2, but what is the coordinate here? What's the label on the axis here? 3 pi over 8. Nice. Okay, so if you think about it, 1 pi is over 8, 2 pi is over 8, 3 pi is over 8, 4 pi is over 8. Okay, so if I start it here, this is positive sine. Forgot my 1. Okay, you guys, I want you to try the last one in your groups, please, or on your own. Three. Oh, 3 pi over 8 negative 1. I tried to label it up here, but the orange is blending in. Yeah, what's wrong? What did I do wrong? Oh, gosh, that's the end of the world. Okay, I cheated and I said it goes from bottom to top. So, yeah, I doubled it. I'm just making one right now.
Well, I assumed we had one from last year, but I don't see it.
I think I just did it in my packets.
Oh, yeah, you're doing the whole thing.
Oh, no. They're doing it. I'm just,
Putting the answer.
yeah,
I
it's
didn't
super
even
easy.
answer that
The
before.
only thing I helped with on this one was the pi over 8 and the 3 pi over 8.
Oh, that's pi over 8. No one's even asked me that. Where? Oh, for that, they're probably just gonna.
Oh, yeah.
I was not.
I was
too scientific.
I was forcing the hand here on that.
Okay, gave them time and then I went over number one.
It's great. But
I just got 37 of them. I put them.
oh yeah, that makes sense. Sorry.
That's not even the biggest, they just look good. With.
Yeah. Okay, let's answer the question at the bottom. There are actually infinite possible equations for each graph of a trigonometric function. What are the only two differences between the infinitely many sine equations? So looking at these two sine equations here, these are good examples. What are the only differences between the two of these? Positive and negative and? Yep, great. Positive and negative and H, that's it. That's the only things that change.